Alright, stop, collaborate and listen.
Okay, now we'll do an example to apply what we did in the last two videos. Got this from Check. A simple gear train is composed of 3 gears. Gear A is the driver and has 8 teeth. Gear B has 24 teeth and gear C has 16 teeth. This is a simple gear train, so we'll just assume that it's an external gear train because that's the simplest that we have. Sketch and annotate the gear train described above. Start off by doing that. So gear A is the driver. So this is gear A. And it's meshing with gear B, which is the largest one, and gear C is the output. These are the shafts for the gears. This is gear A, this is gear B, this is gear C. Since we're used to numbers, this is also 1, this is also 2, and this is also 3. And we're told the number of teeth. Gear A has got 8 teeth, so N1 is equals to 8, and N2 is equals to 24, and finally N3 is equals to 16. So we have sketched the gear train above. Now, what is the gear ratio? Mind you, this is the velocity ratio, also the transmission ratio between A and C. So as you can see, how many meshings do we have? We have this meshing right here and this meshing right here. So how do you calculate the velocity ratio? Remember, in the last video, the velocity ratio was equals to omega 2 over omega 1, the output speed over the input speed, which was also equals to n1 over n2. If you don't know how to derive this, go back to the previous video. So now that we have more than just 2 gears, the velocity ratio is the product of all the individual velocity ratios at each of the meshing. So we've got, this is the first meshing, and this is the second transmission. This is the second meshing. So we'll first calculate VR at the first one. It's equals to the number of teeth. It's equals to omega 2. Which one is being driven? Omega 2. And which one is driving? Omega 1. This is equals to N1 over N2. What is N1? N1 is 8. And N2 is 24. It's 8 over 24. And then VR2. Which one is being driven? Which one is the output? It's 3, omega 3. And which one is driving the other one? So the second gear is driving the third gear over omega 2, which is equals to N2 over N3. If you are confused where we're getting this N2 over N3, please watch the previous video. What's N2? 24 over 16. And the overall velocity ratio is equals to 8 over 24 times 24 over 16. These will cancel. 8 into 8 is 1. 1 over 2, which is equals to 0.5. That's your velocity ratio. Now, if gear A rotates, so we are done with the velocity ratio between A and C. We move on. If gear A rotates at 60 RPM, how fast is gear C rotating? So we know that our velocity ratio is equals to omega out over omega in. Our overall velocity ratio is equals to 0.5. We want to find what we want. How fast is C rotating? C is the output. We want to find the output speed. So the output omega out, which is omega C, is equals to 0.5 times omega in, which is omega A or omega 1. So the speed of omega C is 0.5 times it's 60. What's half of 60? That's 30 RPM. revs per minute. What is the direction of this rotation? Okay, so I told you before that in an external gear train, error meshing, the direction changes. So if gear A was going clockwise, gear B is going to be going anti-clockwise, and gear C is also going to be going clockwise. So 30 RPM clockwise, given that the first one was going clockwise to begin with. Now, we move on to the next question. Oh, isn't it right? If the output torque C is 150 Newton meters, what is the input torque at gear A? So now we're talking about torque. So what is torque ratio? Torque ratio is T out over T in, T2 over T1, which is T of the driven. Let me just out and in are easy to understand. T out over T in, and this is also equals to N out over N in. And in that situation where we have only two gears, like for the first two gears, the torque ratio is just simply N2 over N1. What do you realize? The torque ratio is the inverse of the velocity ratio. In other words, the torque ratio is 1 over the velocity ratio. The velocity ratio for this first meshing was N1 over N2, but the torque ratio is N2 over N1, which means that to get the overall torque ratio, we simply do 1 over the velocity ratio, the overall velocity ratio, which is 1 over 0.5, which is equals to 2. So if the output torque is 150, what is the input torque? So torque ratio is equals to T out over T in, and which that is equals to 2. We want the input torque if the output torque is 150. So what is our input torque? We can make it the subject of the formula. So T input is equals to T out over 2, which is equals to 150 over 2. What's 2 into 15? 7, carry 1, 5, which is equals to 75 Newton meters. Newton meters. I hope this is clear. So first and foremost, we drew our gear train. Gear A, gear B is a simple gear train, and A, B, and C also named them 1, 2, and 3 because we're used to, in the previous videos, we're using numbers. What is the velocity ratio between A and C? There are two meshings. We find each individual velocity ratio and find the product to find the overall velocity ratio. The velocity ratio is output speed over the input speed, which translates to, in expressed in terms of number of teeth, is N1 over N2. So if you can see a pattern for velocity ratio in terms of the number of teeth, it's the output speed over the input speed. But then for the when you're dealing with the number of teeth, it's the opposite. But then for the torque ratio, since the torque is directly proportional to the number of teeth, it's the same. So it's the output torque of the input torque and also the output gear number of teeth over the input gear number of teeth. You can just cram that bit. Yeah, but you know how to derive these formulas from the last video. That shouldn't be a problem. So a good idea before you start this question is to derive your formulas on a little piece of paper and you actually write down your velocity ratio is equals to omega 2 over omega 1, which is equals to n1 over n2, which is equals to d1 over d2. Then you write your torque ratio is equals to t2 over t1, which is equals to n2 over n1. You can write it also in terms of output and input gears, like your velocity ratio is equals to output speed over input speed, which is equals to the number of teeth on the input over the number of teeth on the output. And then my torque ratio is equals to the output torque over the input torque, which is equals to the number of teeth on the output gear over the number of teeth on the input gear. Remember, if you've got multiple meshings, your overall velocity ratio, your overall torque ratio is simply a product of the individual meshings. Thank you. We will do another example on these simple gear trains just to consolidate, but I'm sure you get it by now.